Okay, would you like to talk about completing a square today? So the first question, what is a perfect square? Well, the answer, in our case, is a perfect square trinomial. So a plus b squared or a minus b squared. Let's look at an example. If I tell you I have x plus 2 squared, let's not do 2. Let's do 5. It'll work out better. So if I multiply this out, I have x plus 5, x plus 5. So we FOIL, first term is x squared, outside x and 5 is plus 5x. Inside is plus 5x. And last term is 5 and 5 makes 5 squared. Where you get x squared plus 10x plus 25. And we know this equals x plus 5 squared. Let's look at a couple things here. Note, this 10 here is 5 plus 5. So I add the same number together, I got the 10. The 25 here is this right here. It's 5 times 5, 5 plus 5. So in order to get a perfect square trinomial, I have to add the same number in the middle to get the middle term, that I multiply the same number to get the last term. And it doesn't matter, right? It doesn't matter whether I have a minus in the middle or a plus in the middle. It's going to behave the exact same way. So let's take a look. So x minus 9, x minus 9. I multiply this out. First terms, x squared. Outside x and minus 9. Inside minus 9 and minus 9x. Last, 9 and 9 gives you positive 9 squared, or 81. And again, take a look. The middle term is 9 plus 9. The outside is 9 times 9. So to be a perfect square trinomial, oops. What you add to get the middle term, you multiply to get the last term. So in order to complete the square, we're going to use this fact. So complete the square. Now, let's go back one step here on these two here. Before I talk about it, if I can show the middle term is the same number added together as the last term is multiplied together, then it will automatically be this x is first, plus here, if it's plus here, or down here it's minus, then the last number squared. Automatically, every single time it'll behave that way. So, and we're going to be working with quadratics, so something like this. What do I need to add right here in the blank in order to make this a perfect square trinomial? Well, I'm going to ask, well, what adds together by itself twice to give you 4? Well, that's going to be 2 plus 2. So I'm going to put a 2 right here and square it. Or it's x squared plus 4x. Oops. That shouldn't be there. Plus 4, which will now automatically factor in x. Middle term gives me x. This is going to give me a plus right there. And this here, because done by 2 squared, is 2 squared. B. And we don't have to do that much work. If you know, if this right here is 2 plus 2. 2 plus 2, or if you look, 2 is half of 4. All I'm adding right here is half the middle term. So half my middle term is 10. Half the middle of 20 is 10. So we're going to add 10 squared. Now automatically factor into x for the first term. The middle term gives me minus, and this last term is going to give me a 10. And this will work every single time. I should mention the one caveat here. The one caveat is, for this to work well, the number in front of x squared has to be 1. If it's not 1, it's not going to work out. So if we try it again, what we got? Plus what? All we got to say is 14, half 14. So you're saying, really, we're saying 14 divided by 2 gives you what? 7. So we'll put 7 here. And now we got 1x squared in front. 7 plus 7 gives me 14x. And then the last term is 7 times 7 gives you 49. And automatically it's going to factor into x plus 7 squared. All right, let's do another one here called D. If you know all those examples we've done, the middle term has always been even. And the advantage of even is you divide it by 2, your answer is always going to be positive. Well, not positive, but whole number. Now what happens with this? If I put a 7 here, I have x squared plus 7x plus something will make perfect square. I'm going to do the same thing. If you're going to use scrap paper here, so some people say, well, 7 divided by 2, that's 3.5. You put 3.5, most math people are going to put just put 7 over 2. Half of 7 is 7 divided by 2. So we'll put 7 over 2 squared. Now if you look at this, 7 over 2 plus 7 over 2, does that really equal 7? What's 14 over 2, which is 7. So it does work out. So because that works out, the middle term is 7 over 2 plus 7 over 2. The last term is 7 over 2 squared, or 7 over 2 times 7 over 2. So first term gives me x, middle term gives me a plus or minus, in this case a plus. Last term, 7 over 2 squared. So that's the basics of it. Now we're going to apply it to solving. So we're going to solve ax squared plus bx plus c equals 0. Step 1. Add or subtract c. So that the x squared and the x term are on one side of the equal, and the constant on the other side. 2. If a is not equal to 1, divide everything by a. And this is so we can have what we're starting with up here, right? Up here, That's not very good. Right? And here, we started with the x squared term and the x term all by itself. So that's the whole point of this. Maybe I'll be technical here. If you just have x squared, you can skip this step. If you have 7x squared or 5x squared or 2x squared, you have to do this step. So a lot of times we'll skip step 2. 3. In order to complete the square, what do? We took this middle term here and here, and we divided it by 2. So for us, the middle term is b. So we're going to add b over 2 squared to both sides. Of the equation. And factor. And the good news, because we completed the square, it should factor into x plus a squared. No, let's not use a. X plus r squared, or x minus r squared. And then we're solve using square root method. If you need to pause to jot that down, fine. I'm gonna go ahead and do the example. Solve x squared 6x plus 9 equals 0. Step 1, get those two terms alone. So minus 9. Now we're doing this. Make sure you leave a little bit of space right here, because we're completing the square, which means I have to add something to that term, right? I got to add a term there. So we're going to take half of 6, right? Half of 6 is 6 divided by 2, or 3. And since this is the equation, if I do it to the left side of the equation, I got to do it to the right side. So minus 9 plus 9, again, right? That plus 9 is 3 squared, so I just kind of skipped a step right there. The left side factors immediately. I have x, middle term gives me plus, but that's 3 squared. Equals minus 9 plus 9 is 0. So solving, square root both sides. And even though I know the square root of 0 is going to be 0, I need to put square root on both sides so I follow the process and I don't. Because if I skip it on a problem that doesn't make a difference, I might end up skipping on all problems because I'm just in a rut there. So the square root of x plus 3 squared is x plus 3 equals plus or minus 0, which is just 0. Solving for x equals minus 3. So let's make a couple notes. Factoring is faster than completing the square. Factoring in general is shorter than completing the square. However, factoring can fail. CTS, completing the square, always works. It is always best to try a factor first. It takes less space, it's faster in my opinion, and I think it's a little bit easier. I've had people tell me differently, but you know, if you think that completing the square is easier, that's great. If you don't, it's great also. All right, let's do another one. All right. So I want to solve this one. If I was solving my factoring, I would make this 5 right here into a 0, but I'm not. I want to complete the square, which means I need the y squared and the y term all by itself. We already got that. So we're actually ready to add some value to both sides. So half of 2, right? 2 divided by 2 is 1, where I had 1 squared over here, 1 squared over here. Now, I complete the squares. First term gives me y, second term gives me a plus, and 1 over here, everybody squared, equals 5 plus 1 is 6. Take the square root of both sides. Six is 2 times 3. Both those are prime numbers, so I can't simplify it. Now I still need to get y by itself, so we'll subtract 1. Now recall, I can only add terms together if they have like radicals. -1 and +6 are not like radicals, so this would be -1 plus or minus the square root of 6. This is the preferred way to write your answer. You could say y equals square root of 6 plus or minus the square root of 6 minus 1. You can actually say that. That's okay. And sometimes, because it's plus or minus, you might hear people tell you, well, this is -1 plus the square root of 6, or -1 minus the square root of 6, which is also okay. Just the box answer is a little more compact. All right, how about another example? Okay. Let's see. How about z squared plus 3z plus 5 equals 0. First thing we gotta do, right, is get the z squared and the z by itself, so -5. Z squared plus 3z equals -5. Now we're ready to add stuff to both sides. So here we are, we're going to take half of our middle term. So half of 3. You may say 1.5. I think it works better if we leave it as a fraction. So half of 3 is 3 divided by 2. That's all I can say about it. And square it. Put that over there so we can see it. So factoring z gives me, that's going to be z. 3 halves plus 3 halves equals 3, so we'll put plus for the middle term, and then 3 halves over here equals minus 5 plus 3 over 2 squared is 9 over 4. Before we can go on, we need to combine like terms if possible. So minus 5 is actually a fraction, minus 5 over 1. So the LCD is 4. So for now, the left side actually going to hang out. The right side is actually more work than the left side. So minus 5 over 1, the lowest comes out as 4, so it'll be 4 over 4 plus 9 over 4. Or minus 20 all over 4 plus 9 over 4. So minus 20 plus 9 is minus 11 all over 4. We are finally ready to take the square root of both sides. So square root z plus 3 over 2 squared equals plus or minus the square root of minus 11 over 4. So z plus 3 halves equals plus or minus. Since it's a negative on the inside, right? That negative means we get an I, so we have an I. The square root of 11 divided by the square root of 4. The square root of 4 is 2. Now all we have to do is get z by itself. So minus 3 halves, minus 3 halves. So minus 3 halves plus or minus I square root of 11 over 2. Now, that's a perfectly good answer. The preferred version is actually it's a single fraction, so the preferred version, most likely you see in Hawks or the back of a book, would be minus 3 plus or minus I square root of 11, all of it divided by 2. So that's the preferred version of the answer. All right, let's do one more problem. Let's do the kind of worst case. All the problems we've done so far, right? If you come up here, number in front of, right, of z squared has been 1. Let's do one with the answer when it isn't 1. Let's see how it plays out. All right. So 3x squared minus 5x minus 3. So we know. Let's get the x squared and x term by itself. So the constant will add to both sides. And right there, right? That is not 1. So we'll divide everything by 3. Now, if you're lucky, we divide by 3 into all your terms on both sides of the equation. If you're lucky, 3's all divide out evenly and everything goes great. But we're not. Oh, we're kind of lucky, right? The right side came 1, so that's pretty simple to use. The left side, we got 5 minus 5/3. So half of 5/3. Well, let's think about this real quick. If I do half of a cup, what's half of a cup? It's a fourth of a cup. So I basically multiply that denominator by 2. So half of a third is going to be a sixth. So it's going to be 5/6. Or if you want a little more algebra, we're taking 5/3 and dividing it all by 2. Or if you'd like, 2/1. Which means this is a complex fraction. About dividing a fraction by a fraction, so keep, flip, change. So 5/3, flip the bottom one, and change the divide to multiply. Across top, 5 times 1 is 5. Across the bottom, 3 times 2 is 6. So we're going to add 5/6 squared to both sides. The good news is the left side factor isn't going to factor very bad. First term gives me x, middle term gives you that minus, last is 5/6 squared. And then 1 plus 5 squared is 25, and 6 squared is 36. All right. I need to simplify the right side, so I need to add 1 to 25/36. Since I only have one denominator on the right side, my lowest common denominator is 1, my lowest common denominator is that. 1 times 36/36 plus 25/36. So 36/36 plus 25/36. 36 plus 25 is 61/36. All right. So x minus 5/6 squared equals 61/36. Square root the left side, square root the right side, drop it plus or minus. Square root of 61 divided by square root of 36. =61 is prime, so leave it alone. Square root of 36 is 6. So plus 5/6 plus 5/6. X equals 5/6 plus or minus the square root of 61/6. Or the preferred version, x is equals a single fraction. 5 plus or minus the square root of 61/6. All right, so that's solving an equation by completing the square. Let me know if you have any questions.